everyone, welcome to the course Computer Networks. This is Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. Today I am going to discussing about congestion control algorithms and internetworking. These two topics we are going to discussing in network layer. We are going to discuss in today's session. First, let us see the overview of today's session. First, we have to discuss about what is congestion, and next we have to discuss about what is congestion control. And next we have to discuss about what are the different congestion control algorithms are there to overcome this congestion. Those are the two types of congestion control algorithm, that can be leaky bucket algorithm, token bucket algorithm. These two we are going to discussing in today. And next, after discussion of the congestion control algorithm, next we have to move on to the internetworking. What is internetworking? That is the introduction. And next we have to discuss about requirements of the internetworking. And next, what are the devices we are using for the internetworking. And next, finally, we have to discuss components of the internetworking. These all topics in the internetworking we are going to discussing in today's session. First, let us see what is congestion. Congestion is nothing but too many packets. When too many packets, those can be present in the subnet. Too many packets are present in the subnet, then the performance is going to be degraded. That situation is called congestion. To understand this example, first see this example. Suppose here the sender is there. This is the sender and here is the receiver. This is the sender, here is the receiver. Whenever the data is sending through this particular network, this is the network and channel. So, whenever we are sending the data using that particular subnet, so sender, suppose the capacity of the sender for 1 minute, it can transfer 50 packets. Within the time of 1 minute, it will transfer 50 packets. That is the capacity of the sender. And coming to the receiver capacity, in 1 minute, it will receive only 10 packets. That is the capacity of the receiver. If this scenario, in this situation, suppose in 1 minute, it will send 50 packets. The sender will send 50 packets. But the receiver, only in the 1 minute, it will receive only 10 packets. At that time, there may be chance of the congestion. Means, here the packets are sending 50. Here the packets only the capacity is 10. So, here it is sending 50 packets at a time. But it is receiving only 10 packets. So, here the congestion is going to be happen. Here the performance is going to be degraded at the receiver side. So, this situation is called as a congestion. So, how this congestion is going to be occurred? See, fast sender. Here the fast sender, because here in 1 minute it is sending the 50 packets. Here the fast sender and the receiver is very slow. Means it is receiving only 10 packets in 1 minute. That is the fast sender and slow receiver. That is occurred as a congestion. And the next scenario is occur when the number of packets. When it is occurred when the number of packets sent to the network is greater than the capacity of the network. Means the capacity of this particular network is less than. So here it is the number of packets sent to the network is greater than. I am sending the number of packets, 100 packets I am sending in 1 minute. But the network capacity only receiving 20 packets in 1 minute. So then that time the congestion is going to be happen. These are the two scenarios how the congestion is going to get occurred. And what are the two issues are there in the congestion? If the rate of the packet, means if the rate of the packet arrival means here is the sender, the packet is going to be arrival. Packet arrival is higher than the packet processing rate. This is the processing rate. This is the processing rate. If the packet arrival rate is higher than the packet processing rate, then input queue is going to become longer, because here the input queue is going to be longer, because this is the greater than compared to the processing rate of the network. So, here the congestion is going to be happen. And the next situation is the packet departure. Here is the packet arrival, packet departure time. The packet departure rate is the less than. Here is the less than the packet processing rate. This is the less than the packet processing rate. Then output queue become the longer. That is also the scenario for the congestion. These are the two issues that are facing in the congestion. So, here how you are going to control these congestion? Means this is also called as a traffic shaping. Congestion control is also called as a traffic shaping. So, how you are going to control this congestion? This congestion control mainly refers to it is a technique and mechanism. Here we are going to use the techniques and mechanism to prevent the congestion. To prevent the congestion before it happen. Before it happen, we are going to use the preventions. Remove the congestion after it is going to be happen. Means before congestion happen, we have to go for the prevention methods. After if it is happened the congestion, we have to go for the remove the congestion. So it is about the regulating the average rate of the data flow. Means the data flow, if the sender and receiver is there, the data flow, here it is saying the, if the sender and receiver, if it is sending the 30 packets per minute, if it is receiving only 5 packets per minute, what we have to do here? So we have to regulate that. We have to regulate in between sender and receiver at the average rate. Means sender has to send 10 packets per second. At the same time, receiver receives the 10 packets per second. Like that, we have to regulate this traffic. That is about the congestion control. So it is a method, and congestion control by providing the shape to the data flow. Here there is no shape. If it is sending the 30 packets per minute, if it is receiving only 5 packets, there is no shape. Means here it is sending burst data. Means number of packets we are sending at a time in 1 minute. Here it is only receiving only 5 packets. So to providing the shape to this particular data flow, we are going to use the congestion control to entering the packet into the network. Before entering into the network, into the packet only, we have to focus on the congestion control. Means we have to regulate, we have to shape to that particular data before entering the packet into the particular network. That is about the congestion control. These congestion control at connection set up the time, the sender and carrier. Whatever sender is there, this is the carrier. Whatever sender and carrier negotiate about the traffic shape. Before that only, they have to setting up the time and what is the capacity of the sender, what is the network capacity, all we have to check before sending the data from the sender to receiver only. That is about the congestion control. Mainly it is discussing what? We have to regulate the traffic. We have to providing the shape to that particular data flow before entering into that packet into the network is called as the congestion. So there are two types of traffic shaping algorithms. Congestion control algorithms are the two. First one is the leaky bucket algorithm and the second one is the token bucket algorithm. These two algorithms we are going to use in the congestion control. See, first let us see what is leaky bucket algorithm. Leaky bucket algorithm. So in real time, this is we can assume this is a bucket. In every house we are using buckets, right? This is the bucket. Here is the tap. So whenever we want to use the water, we can use that particular water. Suppose this is a bursty flow. Means sometimes we have to full on the top tap. Means sometimes this tap. Sometimes we are on that is full flow. Sometimes it is going to be a middle flow. Means based on our situation, we are going to use this one. This is a sender. We are sending the data like this. You can assume. So this is the bucket. We are filling the bucket with the water like that. We are filling the data here. So whenever it is going to be, this is the, this is only for the sender, this is the processing data. And next one, whenever it is giving to the receiver, we have here the bucket, in this particular bucket, it is having some hole. That hole is the fixed hole. The hole is the fixed hole. Means whenever it is leaking the water, that is the fixed flow of leaking the water. That is the fixed flow. Fixed hole is there. That's why. So here is the bursty flow. The water is coming any flow. At any flow of it is going to be coming inside the bucket. At the same time, the bucket whatever leaking is there, that is the fixed flow of the data because the hole is fixed. That is the leaky bucket. So here input rate can vary. Means input we can give the water any rate, any flow. That is can vary. It may be give, sometimes it will open, sometimes it will close. After 2 seconds again it will open, like that it can vary. But the output remains the constant because the output whatever it is giving to the receiver, the output is remaining constant because the hole is fixed. That's why output is going to be remain the constant. Here mainly this leaky bucket algorithm smooth out the bursty traffic. Why we are using this leaky bucket algorithm concept here? To smooth out, here by using this particular hole, by using this particular concept, using this particular leaky bucket, we are going to smooth out the bursty traffic. Smooth out is nothing but shaping, regulating the bursty traffic, bursty data. That is the concept of the leaky bucket. So here the bursty chunks means bursty data that are stored in the bucket. Whatever data is coming inside the bucket, that are stored in the bucket and send out the average rate. Here we are taking the burst data into the bucket, but whenever it is sending out, it is coming into the average rate, that is the fixed rate. So consider this example. Here it is the bursty data. How it is bursty data? See here. So in 2 seconds, 0, 1, 2. In 2 seconds, we are sending the data 12 Mbps of data. The speed is 12 Mbps. In 2 seconds, we are sending the 12 Mbps of data. So here in 2 seconds we are sending 12 Mbps of data. That I wrote here. See, 12 Mbps that can be sent in the 2 seconds. So and next from 3 to 6 it is idle only. Means we are not sending any data here. The tab is on, that is the bursty data. Means bursty means full, we can on this the tab, that is the 12 Mbps we can assume. So here in 2 seconds we are sending the data 12 Mbps. At the same time from 3 to 6 that is empty only. We are not sending any data. That is in idle mode. Here it is the idle mode. We are not sending any data here. So the sender is silent. Means the tab is going to be closed. After some time, after 7 to 10 again I am going to on the tab. That is also at the same time. Here it is 2 Mbps speed. What is the speed here? 2 Mbps means this is 7 to 8, 8 to 9, 9 to 10, 3 seconds. In 3 seconds, we are sending the data 2 Mbps of data. That is 2 Mbps into 3 seconds. So this is the idle time. So from 3 to 6 it is ideal only that is only I wrote here as silent. So the total data, what is the total data in 10 seconds we are sending? See, this is the 24, this is 24, this is 0 and this is 6. The total of this is 30 Mbps as the data I sent. This is 30 Mbps data I sent. But in real, but whatever, if it is coming to the using this leaky bucket, how it is going to be sent the fixed data date? How we are going to send this particular data in a fixed form? See here the total is 30 Mbps of data, 30 MB data is going to be there. That particular data, how we are going to fixing into the 10 seconds? How we are going to fix into 10 seconds means in the total 10 seconds we have to use. Because in bursty data, sometimes it is sending the high flow of the data, sometimes it is idle, sometimes it is going to send the data. This is the case of the bursty data, means this is the bursty flow. And coming to the fixed rate flow, we have to use total 10 seconds. We have to use total 10 seconds, whatever time is there, we have to use total time with the fixed flow of the data. How much time it will take? See, total is 10 seconds. The data total data is 10 Mbps data. How it is going to be transferred in the fixed rate? See, 10 into 3 is nothing but what? 30. Means we are sending the data 3 Mbps speed. We are sending the data 3 Mbps of the data in the 10 seconds. That is the condition, means that is the fixed flow of the data. Like that we have to send the data from the sender to the destination. Means from sender is the bursty flow. Using the leaky bucket, we are going to regulate that particular data using the some fixed hole is there. Based on that, we are going to send the data to the receiver. So these leaky bucket may drop the packets if the bucket is going to be full. Means suppose whatever bucket is there, if this particular bucket is going to be full, total is going to be full, that time what it will do? It will drop the packets. It will discard the packets if the bucket is going to be full. Means suppose if the flow is continuously going to be happen, so suppose after some time the bucket may be going to be getting full, that time it will discard the packets. That is the condition. So mainly these congestion control algorithm in the leaky bucket. So this leaky bucket algorithm mainly used for regulating the traffic. To regulate the traffic means to regulate the data flow from the sender to the destination, we are going to use the leaky bucket algorithm. So here some disadvantages are there in the leaky bucket algorithm. Let us see what are the disadvantages are there in the leaky bucket. Firstly, it is very restrictive. There are lots of restrictions are there for sending and receiving the data. That is very restrictive. So and not credit and ID lost. Means whenever the data is sending from the sender to the receiver, in previous scenario we already seen that here it is idle, means we are not sending any data in this particular time. So in this scenario here we are not sending any data, this is waste of time only. So that is also one of the, we are not crediting, we are not giving any data in that particular time when the host is idle. That is also one of the disadvantage. If the host is not sending for a while, suppose if the host not sending for a while, then the bucket is become empty. Suppose if this is the case, here the water is the flow is going to be fixed. At the same time, it is going to be leaky bucket, right? Here is the leaky flow, that is the fixed leaky bucket. Here is fixed flow. After some time, it is off only. The tap is going to be off. That time after whatever water is there in this bucket, this is going to be getting time after some time. That bucket will become empty. The host is not sending the data. What we have to do now? If the host is burst data, if it is sending the burst, this is the one of the disadvantage. Means if it is empty, means suppose the leaky bucket is leaking the water, but it is the tap is going to be off. The sender is not sending any data. Means then again it is going to be idle only. That is one of the disadvantage. And the next one is the, if the host has bursty data, but suppose if it is sending the bursty data, the data flow is too high, then that time it allows the data rate is an average rate only. Means the flow is bursty also. The flow, whatever flow is coming from the tap, that is bursty only. But whatever data is receiving from the receiver, that is only the average rate only. Means that is a fixed flow only. So the time when the host is idle, that are not going to taken into the account. Whichever time, see, this is the time is the idle time, right? This time is not going to consider into the account. That is also one of the disadvantage into the leaky bucket algorithm. Means the time from the in the previous scenario, see here from the 3 to 6, it is idle only. In that time, we are not sending any data. That is also one of the disadvantages of the leaky bucket algorithm. So, see this example in this scenario, how we are sending the data. First, where the packet is going to be arrived. See, first we have to check whether the bucket is going to be full or empty. We have to check. If it is full, whenever the packet is arrived, that time we have to check the bucket. If it is full, if the queue is going to be full, queue is nothing but here it is bucket. If it is full, it will discard the packet. If it is empty, if it is no, if the queue is not full, that can be stored into the queue. That can be stored into the bucket. At the same time, this is the bursty flow. Till here, it is the bursty flow. This is bursty flow. And coming to here, whatever process is there, processor, what it will do, this is, can be sent the data, this can be receive the data at the average rate. Because here we applied the leaky bucket algorithm. It can remove the packets at the constant rate. Means here it is the fixed. So whatever it is there, it is a constant rate. So here we have to receive the data at the fixed rate. Here it is the fixed rate. We are receiving the data. So that can be given to the receiver. That is the departure. This is the process of sending the packets from the bursty flow to average rate. So next one, token bucket algorithm. To overcome these all disadvantages, we are going to use the token bucket algorithm, because there is a host is idle sometime. At the same time, there are many restrictions are there, lots of disadvantages are there. To overcome that, we are going to use the token bucket algorithm. This token bucket algorithm mainly talking about, it allows the idle host. Here there is no idle host. It allows the idle host to accumulate to credit the future in the form of the tokens. Means when the host is idle, that time we are going to collect the tokens. That process that will do in the token bucket algorithm. That is the main advantage in the token bucket algorithm. For each tick of clock, means tick of the clock is nothing but for each second, the system send the n tokens. Suppose per 1 second, it will send the 100 tokens. In 1 second, it will send 100 tokens, if we can assume. Means for each and every second, the system send the n number of tokens into the bucket. System remove 1 token for every byte. What system will do at this time of removal? 1 token for every byte of the data that is going to be sent. So see here, host idle time is going to be 100 ticks. Means suppose here 100 seconds is there. 100 seconds are there. In 100 seconds, what is the number of packets we are sending? How many packets we are sending? 100 packets we are sending. Means total is 100 seconds. We are sending the number of packets 100 per second. So how many total tokens are going to be collected in that particular bucket? 100 into 100, that is 10,000 tokens are going to be collected. So when that particular tokens are going to be 0, if the tokens are going to be completed, if all going to be 0, then the host cannot send any data. Means if the tokens are not there, we are not sending any data. The token bucket allows bursty traffic that can be regulated at the maximum speed. Here also we are focusing on the bursty traffic that are going to be regulated the traffic. See how we are going to regulate the traffic using the token bucket algorithm. This is the diagram for the token bucket algorithm. See, first what we have to do here. First, here is the packet arrival. Here is the packet arrival. We are checking this is the bucket, right? First, what we have to do? First, we have to check whether queue is full or not. We have to check. If it is full, we have to discuss the packet. If it is not full, if it is no, this is yes, this is no. If it is not full, we have to enter into the queue. Whatever packet is there, that is going to be allocated into the queue. That is the process. So what processes will do? Here 1 token is added per tick. Means already say, suppose per tick means second. For 1 second, we are going to add 1 token. For 1 second, we are adding 1 token. This is the process here. In these examples, see here, for 1 tick, we are going to adding the 1 token in this particular bucket. So, this bucket, whenever process, what it will do, 1 token is going to be removed. Means after getting the token only, 1 token is going to be removed. Then only, that time only, the packet is going to be collected from the queue. Whenever the token is there, then that time only the packet is going to be collected from the queue. The process, what it will do exactly, it will collect the token. At the same time, when the token is available, then that time only it will remove the packets from the queue. Then that is going to give into the destination. That is the process. As per and discarded per cell transmitted. That is the process. Means when the token is available, that time only we are sending the packet to the receiver. That is the process. See here, this is the process of how we are going to collect the tokens, how many tokens are collected. So at the same time, the tokens, when it is going to be 0, host cannot send any data. If there is no data is going to be sent, that time there is no, if there is no tokens means what? There is no data in the particular sender side. That is the problem. And token bucket algorithm mainly talking about the velocity traffic. Suppose if we combine token bucket and leaky bucket algorithm, what it will happen? The two techniques are there. Coming to leaky bucket algorithm. So leaky bucket algorithm, what it will say exactly means, leaky bucket is algorithm is talking about regulating the traffic. We have to regulate the traffic. And coming to token bucket algorithm, it is talking about crediting the ideal host. Means we are not going to, in previous case in leaky bucket algorithm, the host is going to be ideal sometimes. But in token bucket, we are crediting that particular ideal host. These are the two techniques, right? That are the two techniques of the leaky bucket and token bucket. If we combine these two techniques, how we are going to combine? See here, if the leaky bucket is applied, if the leaky bucket is going to be applied after the token bucket, the rate of the leaky bucket is needed to be higher than the rate of the this particular token bucket algorithm. Tokens dropped in the bucket. These are the two techniques in the congestion control algorithm. And coming to differences between leaky bucket and token bucket, what are the main differences are there? So in token bucket, the token is dependent. In leaky bucket, token is independent. Leaky bucket, the token means where it is a bursty flow. Here it is, token is dependent. When the packet is there means then only the tokens are going to be available. That's why it is dependent. If the bucket is going to be full, if the bucket is full, the tokens are going to be discarded, but not to the packet. That is token bucket. And coming to leaky bucket, if the bucket is full, the packet and data is going to be discarded. Automatically, it is going to be discarded. Coming to here, it is only full. If it is full, the tokens are going to be discarded, but not to the packets. So, in this token bucket, packets can only transmitted when there are enough tokens. When it is in token bucket, already we discussed, right? When the tokens are available, that time only we are sending the packets. And packets are transmitted continuously. Here there is no tokens or nothing in the leaky bucket, only fixed flow is there. Packets are going to be transmitted continuously. It allows, in token bucket, it allows large burst to be sent faster rate after the constant rate. That is the token bucket. And coming to leaky bucket, it sends the packet at the constant rate. Because here the fixed hole is there. Here is the fixed hole is there. We are sending the packets at the constant rate. And coming to here, what? It is sending bursts to send the faster rate after the constant rate. It saves the token to send the large burst. It saves the token in the token bucket. It does not save the token because there is no tokens in the leaky bucket. It does not save any tokens. These are the differences between the leaky bucket and token bucket algorithm. And coming to the next topic is internetworking. What is internetworking exactly? Internetworking is talking about the process. It is a process or technique. It is connecting the different networks. Internetworking is nothing but connecting the different networks that can by using the intermediate devices. This is one network. This is another network. For connecting these particular network to another network, we are going to use some intermediate devices. That is called as the internetworking. That such as routers, gateways, repeater hub, all are going to be there, right? In network devices, already we discussed different devices are there. What are the different devices are there? Repeater, hub, gateway, switch, gateway, switch, bridge. These are the different types of network devices. Means connecting from one network to another network. Connecting the different network, we are going to use some intermediate device using the routers, gateways, different devices. That is nothing but the internetworking. It is a standard reference model for internetworking. For internetworking purpose, we are going to use the standard network reference model, that is OSI. OSI is Open System Interconnection. Any interconnection among between public, private, commercial, industrial or governmental computer networks that may also be defined as an internetwork or internetworking. That may be any interconnection. That interconnection, it may be any way. That may be public, private, commercial, government, anything. That may be defined as a internetworking. That is about the internetworking. This internetworking ensures the data communication among the different networks that can be owned by the different entities using a common data communication and the internet routing protocol. This internet is the largest pool of the network. Means internet is having the number of networks are there that are geographically located throughout the world. Number of protocols are going to be used for connecting the internet, but these networks are interconnected. Why we are connecting? So this is the total world. Suppose if you assume how we are connecting this total world, because there is an interconnection between the network using some protocol stack, that is the TCP/IP. This internetworking is only possible when all the connected networks. When it is going to be possible, all the connected networks use the same protocol stack or communication methodologies. Then only it will possible for the interconnective between the networks. This is about the internetworking. What are the requirements for this internetworking? So, internetworking is mainly talking about providing a link in between the network. From one network to another network, we are providing some link. That is the first requirement. At minimum, a physical and link control connection is going to be needed. That is the link in between the network. And it also provides for the routing and delivery of the data in between the processor and the different networks. And the next requirement is it providing the accounting services that keeps track of use of the various networks and routers that can maintain the status of that particular network. And it is also providing the services that are going to be without requiring modifications to that particular networking architecture of the constituents network. These are all the requirements of the internetworking. What are the different devices we are going to use in these internetworking? Already we said routers, bridges, repeaters, gateways, switches, all are going to be used in this internetworking for connecting the different networks. Already we discussed repeater and hub. Repeater, hub comes under which layer? These two comes under the physical layer. And the next one, bridge, switch comes under the data link layer. And the next one, gateway and routers. These two comes under the network layer. These are the devices. Whenever we are going to send the data using the physical layer, we are sending the data in the form of bits. If we are going to send the data using the data link layer, we are sending that data, we can call it as the frames. If it is the particular data is going to be transferred into the network layer, that data we can call it as a packets. So these are the different devices we are going to use for the connection in between the different networks. These are the devices. And next one is the components of the internetwork. What are the different components of the internetwork? First one is the campus network. Campus network is talking about locally connected users in a building or a group of buildings. In the particular campus only, we are going to use the campus network. It generally uses the LAN technologies. So suppose in particular campus, we are going to use the connections building to building, within the building. For that purpose, we are going to use the local area connection. That is the campus network. Using LAN only, we are connecting to the campus area network. Wide area network, WAN. That is WAN. It is a distance campuses connected together, usually through the connection provider such as a telephone company. Telephone company is the example for the wide area network. And remote connections. What is remote connections here? Linking branch office and mobile users to a corporate campus. They are generally dial-up links, low bandwidth, dedicated WAN links are going to be there. Means suppose taking the bank, if consider taking the bank, this is one bank at one place, but it is having number of branches are there. How we are going to linking all the branches at one place? That is the remote connections using the dedicated WAN links. These are all the components of the internet network. And coming to the summary, today we discussed first what is congestion, and next we discussed what is congestion control, and next we have seen what is congestion control algorithms are there, like leaky bucket algorithm, token bucket algorithms. This is all we have seen in today's session. Next we discussed internetworking, what is internetworking, about internetworking and requirements, what are the devices are used in the internetworking, components are there in the internetworking. These are all we have seen in today's session. Thank you.